Hello everyone, this is Dr. Lennon with the Test 1 review for Math 156. So roughly the material will be over what we covered in the first 3 chapters. So I've just kind of made a little checklist and we'll do some example problems, and it should be pretty straightforward. So there'll probably be some multiple choice questions and also some ones you need to work out. We won't be using anything besides a calculator for this test. So next test probably will be using more StatCrunch, so we'll have the use of a computer or tablet, something like that. But for this one, I want to keep it pretty simple and just stick to using a calculator. So let's look through the checklist. So one of the things that we looked at a lot was population and sample. So a good source of material for that is going to be the group activity number 1 solutions. I think people were pretty good at this. Remember, one of the things that's in play here is you want to know what is trying to be studied. So you want to look for keywords. Usually it's pretty clear. There's a little bit of inference on one of the problems. So for example, 3D here, it says annual incomes of all 33 employees of a restaurant. So because it's all the employees, that's why this is population versus a sample. The trickiest one was probably 2D. And again, there's language in there that indicates population rather than sample. So it says the number of houses sold by each of the 10 employees. So each of the 10 employees hints at the fact that it's all of them. So that's all that are is 10 employees at this real estate agency. So for that reason, we'd call this a population. But yeah, just look over those. And the only ones that tend to be tricky are examples kind of like 2D or 3D. All right, what's next on the checklist? Understanding member, variable, observation, time series versus cross-section data. So again, the first question on the group activity was a good example of that. So the entire table itself, that's going to be considered the data set. The variable is the compensation, that's highlighted in red, and the ones that I've highlighted in yellow, those are the observations. So those are the actual values that the variable varies over. So those are each observations of that variable. The members are the CEOs that I've highlighted in blue, and this is cross-section data because it's all coming from the same year, just different CEOs. If we were looking at, say, a single CEO and his annual salary over a multitude of years, that would be time series. So you're looking at how things change over time for time series data, whereas cross-sectional data is kind of comparing their landscape at the same point in time. All right, number 3, compute variance and standard deviation from a data set. So we just want to do something small here. It's going to be a by hand example. So the easiest way to do that typically is making that chart. So let's compute the variance and standard deviation of a pretty small data set. Let's say we're working with let's say we're working with some numbers like this is I don't know, let's say we have 4, 6, 7, 12, 14, and 20. So 6 values. So remember the formula for standard deviation. Standard deviation is, there's 2 depending on whether you're working with a population or a sample. So typically what we're doing is we're summing up all the differences of the squares of the deviations. Then we're dividing by either n or n minus 1. In this case, we'll do n minus 1 for a sample. If it was a population, we'd be dividing by n. So what we want to do here is we first want to find the average. So x bar is just the average. So that's going to be 4 plus 6 plus 7 plus 12 plus 14 plus 20. Divided by the total number of values, which in this case is 6. So let's compute that. punching it into my calculator. So 4 plus 6 plus 7 plus 12 plus 14 plus 20. All right, and divided by 6. So that gives us 10.5. And then basically we just kind of make a chart to organize ourselves a little bit better. So on the chart, we're going to have each of the values, then the deviation, x minus the average, and then we're going to look at squaring each of the values in that column. So x minus x bar squared. So let's write down our values here: 4, 6, 7, 12, 14, and 20. And then from each of them, we're going to subtract 10.5. So we get negative 6.5 here, negative 4.5, negative 3.5, 1.5. 14 minus 10.5 is 3.5. And then 9.5. 20 minus 1/2 is 9.5. So let's square each of those values to come up with the last column. So one second, my calculator's in a funny mode. Can't find the one that switches. There we go. Okay. So 6.5 squared is 42.25. 4.5 squared is 20.25. 3.5 squared should 12.25. 1.5 squared should be 2.25. 3.5 squared is 12.25. And 9.5 squared should be 90.25. So let's add up this last column. So we total it up and we get 179.5. So the sample standard deviation here. So sample standard deviation is, so actually that 179.5, that's the, well, I'll explain to you the variance in a second, but for the sample standard deviation, we're going to do the square root of 179.5. So notice that's the sum of all the deviations that we had over here. So that's the top underneath the square root. Then we need to divide by n minus 1. So n is the number of observations, 6. So we're going to be dividing by one smaller instead, 5. So this comes out to where's the, there we go. So 5.99 if you round it 2 decimal places. And the population standard deviation, that is going to be, instead of n minus 1 in the formula over here, so technically this is the sample. If we wanted to write down the same formula for the population standard deviation, it would look very much alike, but that bottom number is just n rather than n minus 1. So it would still be the sum of all these x minus x bars squared, but we're dividing by n. So it would be the same thing, but we'd be dividing by 6 rather than 5. So there we go, the population standard deviation, if we do that. So divide by 6 this time, and then take the square root, and we get 5.47. Okay, so that's it for computing the sample and population standard deviations. The variance would just be the square of the standard deviations. So if you wanted to find, say, the sample variance, so I can fit that over here probably. Sample variance. That's just going to be your standard deviation squared, so that would be 5.99 squared, which would be 35.88. And your population variance would be the square of 5.47. So what does this come out to? So 29.92. Alright, so those are your two values for both the sample and population level. So you'll need to be able to compute one of these similar length by hand. So let's go back to that test review. What else do we have? So a frequency and a relative frequency table from raw data. So alright, so the frequency and relative frequency table. And also the cumulative relative frequency and cumulative frequency. So let's just take something maybe red, blue, yellow is some type of objects in a data set, so some categorical data. So let's say we have red, blue. Sorry about that, my phone wasn't on silent, so I had to pause the video. Anyway, so again, we're just going to make a frequency and relative frequency table. So to do that, we're going to take about 10 data values. So again, these will be given to you. You wouldn't have to do that yourself. Blue, yellow, and then let's say we have yellow, blue, blue, red, and red. So the frequency table, we just have the type of thing, then the frequency, then we wanted to do the cumulative frequency, then the relative frequency, and then we could do the cumulative relative frequency. So the cumulative part, that's just essentially a running total, nothing too fancy. So we have different types of things. We have red, blue, or yellow. And you just have to go through and count. So red, there's 1, 2, 3, 4 occurrences of red. There's also 4 occurrences of blue and 2 occurrences of yellow for a total of 10. So the cumulative frequency is just the running total. So you'd have 4, then 4 plus 4 makes 8, then 4 plus 4 plus 2 makes 10. The relative frequencies are also pretty easy. You just compute the percentage. So 4 out of 10 total objects gives you 0.4. 4 out of 10 for the blue is also 0.4, and for the yellow, 2 out of 10 is 0.2. And then to do the cumulative relative frequency, you just do the running total of the relative frequency column. So that's going to be 0.4 here. 0.4 plus 0.4 makes 0.8, and then you should always have 1 as your last entry for a cumulative relative frequency. Okay, so with my recording software, I can only record up to 15 minutes, so I'm going to upload this, and then we will do a second part of the video to finish off the remainder of the topics. So I'll see you then.